So orchestration main bricks. What I'm going to explain now actually exists in all orchestration solutions in a way or another, whether it is commercial or it's a community or open source initiative. And these are the foundation that any orchestration rely on. Let me start with what we call a design time environment. And you will always see in the orchestration domain, there is something called design time environment and runtime environment. The design time environment, where you do the modeling for the service, where you do the testing, certification, whatever. And the runtime, that's actually where the magic happens. That's the orchestration brain. It might look a little bit a basic definition, but that's the case if you review the own app. And we will go to the own app slide, for example. I will map this a term or understanding to the own app slide. So what's happening on the design time environment? You see terms like modeling, testing, certification, and CI/CD, and many other things. So I'll start with the modeling. Okay. To do an orchestration for certain service, regardless if this service is a resources one or a real service, you need to do a modeling for some sort of descriptor, a service descriptor that actually shows how is this service structured, what is the structure of the service, what are the components of the service, how do you build the service, like for example, you go and instantiate X and then scale Y, or what is the flow, the exact flow, what are the policies linked with the service, for example, how do you scale, how do you heal. So actually, imagine that you are doing one slide explaining a service. It is the same, but in a modeling language. Like you do the modeling of the language that any kind of orchestrated engine can understand the model. And whenever he gets a request from an external system to trigger this service or instantiate this service, he can just take a look to this service model and understand exactly what he needs to do. So that's a design time. It's usually linked with a staging environment or a lab environment so that you can do the testing. What I think the testing, that whenever you do the modeling, you do a testing instantiation or a testing invoking of this service, and then you do some sort of certification. For example, if this service is to run on Red Hat or Mirantis or Canonical or Kubernetes or whatever, so you do the whole set of modeling and certification and testing on staging, and then you go to the live sites or the commercial sites. So any kind of modern orchestration have this kind of design time environment, and vendors compete in the digital experience of such tools, how to give a nice experience for developers and the customers' teams. And then you have a very important brick, which is the runtime catalog. And please always keep in mind what I've shown you in the tab, where you see the catalogs. And catalogs exist in product and in service and resources domain. So in the catalog, actually, the output of the design time environment, the modeled service, the templates, the packages are all imported in the catalog. So catalog will have the descriptors that describe the service or describe the VNFs. For example, in NFV domain, we have the NS network service VNF descriptor based on Tosca or Yang. Tosca is the most adopted. We have the CSAR packages, like the packaging of the VNF or the packaging of the network services. We have the service decomposition, like for example, a definition that this service, to fulfill service X, you have to decompose the service to instantiate Y and Z and A, B, and C. So that's how the service is decomposed into, I would say, sub-services or VNFs. So this kind of decomposition, it is there in the catalog, and it is a result of the modeling done on the design time environment. You have the workflow composition, and the term workflow is a very, I would say, term that is coupled always with the orchestration. So workflow is important because it draws a certain workflow logic that orchestrator have to follow to instantiate the service, for example. For example, if the service is composed of a VNF A and B, the workflow mandates that you instantiate A, then B. You cannot instantiate B, then A. And if the service gets more complicated, the workflow gets more complicated. And in the workflow composition, you also get a rollback scenario. What if scenario? Like what if you get an error, how do you roll back? So all these logics are defined in the catalogs as part of the service descriptor or the VNF descriptor. You have the LCM policies, lifecycle management policies. when do I scale? For example, if CPU reach 80%, or if the attached success rate drop to 70, all these logics are there as part of the policies. It is there in the catalog. Monitoring artifact. What do I need to monitor for sake of lifecycle management? And that statement is important. Why? Because any function can output thousands of metrics. And these thousands of metrics are usually collected by EMS and then sent to the OSS systems for FM and PM. But for sake of lifecycle management, the orchestration commonly monitor a subset of these functions. So what are these metrics that need to be monitored by the orchestrator? These are all defined in the catalog, or the descriptor that is there in the catalog. Scripts and configuration, like what we call D0, D1 configurations, are all there in the catalog. And many other things there in the catalog. Actually is the heart of the orchestrator, and it's a very big dependency between the orchestrator engine and the catalog. Catalog can be external, nothing prevent conceptually to doing that, but usually it is there in one orchestration solution. And then there is a main brick, which I called it the closed control loop. The closed control loop usually have three things: the orchestration engine, the monitoring utility, and the policy engine. Okay, so what is closed control loop? Usually as an orchestrator, you do something, you execute something. For example, you instantiate a VNF, a CNF, you instantiate a service, and then you do monitoring for the artifacts defined on the catalog. And when you see a certain trigger or a certain input, you detect a need to do another action, for example, to scale, to heal. So that's the closed control loop. And that's a typical requirement from any orchestrator, to have the capability to do closed control loop. So the what to monitor, it is there in the catalog. What is the action to do upon monitoring? It is there in the catalog, it is there in the template. And the policies are statically defined also in the template. It can be more advanced if the policy is not statically defined, but it can be an output of a certain machine learning model or machine learning solution that is implemented to have these policies dynamically defined. And then the last brick, and the main, also one of the important bricks of the orchestration, which is the active inventory. So whenever orchestrator fulfills something, like I am an orchestrator, I managed to instantiate a service, I have to update the inventory that now this service is up and running. That's why in the inventory, in any layer, in any orchestration, in any domain, you can see the list of all service instances instantiated, list of VNF records instantiated, the full NFVI inventory, like what are the data center utilization, data center capacity, that's how many of them, or the percentage utilized and the percentage free, and any kind of inventory according to the domain, you will find in the active inventory. So from now on, I hope this slide is clear. Whenever you assess any orchestration, search on these four main bricks. I'm sure you will find them. Okay, and I will show you that. And if you remember, that was the intent, that we take this slide and we take the previous understanding, and then we go to the examples on the telco market, and then we try to map these blocks to the telco orchestration solutions.